Good day, students. Today we want to solve problem under electrolysis. The first thing to do is to write the parameters. Now calculate the time in minutes. T minute to electroplate an article of area. The area equals 300 centimeter cube with a copper. With a layer of copper 0.06 centimeter thick. This thickness is the length of the thickness. Let's call it L. 0.06 centimeter. 0.06 centimeter. If a constant current 2 ampere is maintained, assume that the density of the copper density is 0.8 gram per centimeter cube, and that 1 coulomb liberates 0.0033 gram of copper. You will notice that they didn't give us directly like the electrochemical equivalent of copper is this, because they know that, or that they know that if they tell you like that, you will know that Z, which stands for electrochemical equivalent, is standing for that value. But since you know the unit of electrochemical equivalent, you will notice that 0.0033 gram is standing as the electrochemical equivalent. How do you know? I told you that electrochemical equivalent, the unit is gram per coulomb. You know that one. Immediately you know that one. You see what they did here, and that 1 coulomb liberates this gram of copper. And if you remember Z to be equal to mass under electrolysis equals to ZIT, and your Z, now we make sure the formula equals M over IT, and M equals Z equals M over IT, which is M over Q. The unit of under electrolysis, the unit of the mass is gram. This coulomb, that's the unit of the electrochemical equivalent, is gram per coulomb. Okay, now if you now look at this, they said, and 1 coulomb, which is this, liberates this number of grams. That means that this one is standing as our electrochemical equivalent. Don't look at it as it's a mass. No, because of this, what they said, and that 1 coulomb liberates this. There's a unit of gram per coulomb because of this. 1 coulomb per coulomb of this gram. Don't make mistake of saying because it is gram is now the mass, standing for mass. No. Is that okay? That means that our electrochemical equivalent Z equals 0.00033 gram. Is that taken? Gram per coulomb. It's not mass, it is gram per coulomb because of it liberates this per coulomb because of this value of 1 coulomb. Is that okay? But let me say you are not giving, you didn't say 1 coulomb liberates this. That means that this one is now standing as our mass. But because of 1 coulomb liberates this, it's standing as gram per coulomb, which is for Z, electrochemical equivalent. Now, what are we looking for? Calculate the time in minutes. What you now do is that since you have this formula to be like this, and you know that we don't have mass in this question, what you need to do is to look for our mass. And don't forget that density rho equals mass M over volume V. And we don't have mass, we don't have volume, but we have density. Now let's look for our volume. You can get our volume from here, because we have area and the length. Volume equals area times thickness. Okay, now volume equals, what's our area? Area is 300 multiplied by thickness 0.06. okay, now be 300 times 6 over decimal stand for 1. I mean, if you shift twice, add to 0, cancel this. You have your volume to be 18 centimeter cube. I've gotten our volume. We can now come to the mass. Is that okay? Mass M equals density times volume, and you have your mass now. So what our density? The density of the copper. Okay, we are looking for mass of the copper. Density of the copper by the volume of the copper. Okay, call it volume of copper, C, VC, which is VC. Now, what's the density? 8.8 times 18. When you multiply that, you have 158.4 gram. Okay, I've got the mass of the copper, and you know that we are looking for the time in minutes required to electroplate an article of area of this with a layer of copper of this thickness. Now, since you know that, we come to the formula, which is this M equal to ZIT, and you know you have time there. M equal to ZIT. Make time the surgery on the formula, equal to M over divided by ZI. What's our mass? We have 158.4 divided by Z. We have as 0.00033 times current. Current is 2. Okay, so you multiply the denominator, 0.00033 times 2 times 6,600.0. You have 0.00066. Okay, our time now, because when you divide it, you have 240,000 seconds. 240,000 seconds. But you are told that it should be in minutes. Don't forget that 60 seconds make 1 minute. Now, this type of seconds, 240,000 seconds make how many minutes? X. Okay, now you cross multiply, you have X 60, X equals 240,000 divided both sides by 60. You still cancel 60, 0 cancels 0, 6 here 1, 6 here 4. X equals 4,000 minutes. Okay, the time in minutes required to electroplate an article of area of 300 centimeter cube. This is the value of the time. This is the time it takes to electroplate it. Okay, this is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.